Okay, in this video, I'm going to be looking at solving triangles. That's 5-8, 7-1, and 7-2. Here, you really need to watch it. Okay, this was hard material, and I never was quite confident that you really thought through things like you needed to. You have to be careful about whether you actually have a right angle or not. So remember that if you don't have a right angle, if there's no right angle, okay, you can't use a squared plus b squared equals c squared or SOHCAHTOA. Okay, so you have to use law of cosines or you have to use the law of sines. And there's some really tricky things that happen on that. So it's important that you go back and review this chunk of material. Okay. So what I usually do first is I just draw out my triangle. So B is 25 degrees. So, and A is 21.6. So if I make this angle A, then A would be right here, little a, 21.06. Let me make sure I have that right. Yeah, 0.06. And then B would wind up being 17.8. So it's going to be coming from here and be 17.8 is correct. So this is little a, this is little b. There's where C would be, and here's little c. Solving the triangle means finding all the remaining pieces of it. Okay, so I'm going to go ahead and draw this all the way down here, and I'm going to look. So since I have a side, opposite, and angle, I'm able to use the law of sines. So I'm going to do that, okay? And what I'm going to be looking for is this angle right here, angle A. So I want that to be on top left. It makes it a lot easier. So law of sines just says the sine of angle A over the length of side A would equal the sine of, say, angle B over the length of side B. And so I'm able to then use that to find the sine of A. So I'm going to take 21.06 times the sine of 25 degrees, divide that by 17.8, and I'll be rounding that, but I'll be hanging on to a lot of decimal places here. So I'm going to take 21.06 times the sine of 25 degrees. Make sure that you're in degree mode. Okay. And then I want to divide that by 17.8, and that turns out to be about 0.5000 if I round to 4 decimal places. Well, that doesn't happen often. That turns out to be an angle that you might recognize. So the angle that has a sine of a half is actually a 30-degree angle. If you recognize that, you can do it. Most of the time, this won't be exact one that you can do that way. So you normally have to go in and do A equals sine inverse of that right there. Okay. And so if you did that, it would tell you what we already know in this case. So it would turn out to be 30 degrees. All right, so once you get that, okay, then, and let me go over here and collect everything we're trying to find. So I need to get all the angles and then all the sides. Okay, now what you got to be careful about is this. This was the tricky part about the law of sines. It seems like a super easy process, but your calculator, you now know a little bit more than you did before. The calculator, when you do inverse sine, gives you an angle within the first or the fourth quadrant. Well, this angle that was 30 degrees was over here in the first quadrant, but there's an angle that could also be an angle in a triangle in the second quadrant. And you see this angle right here, in here, the reference angle here is 30 degrees, just like this one's 30 degrees. So you have to consider that. So if I do 180 minus the 30, that's 150. And that could be an angle in this triangle. So really I have that A could be 30 degrees, but now I also know, and I'm going to use a prime on this, that A might be 150. Because if that were 150 and I add 25 to it, I still have room left to be able to get angle C. All right, and what's happening is the reason that happened is that 17.8 might actually be over here, where A prime is, let me move that 25 over a little bit. Okay, where that A prime right there is the obtuse angle of 150 in this case, or over here 30, and that 17.8 is this length here. It just could swing and be over there. So C might turn out to be that whole angle, or C prime is just that little piece right there. All right, so let me put in what I know and what we have left to find. Okay, so we knew B was 25 degrees on both of these. Okay, there's no change there, but then C and A could be something else we noticed. So if I know two angles of the triangle, I can find the third one. So C prime is going to be 5. C, if you have 30 and 25, that's 55. So you can take that from 180 and get 125. So you have all of the angles now. Now you were given little a, and that was 21.06, and that's got to be the same even down here. Okay. You were also given little b was 17.8, so all you needed was c, but don't be tempted to use the Pythagorean theorem. You can't. It's not a right triangle. So what you do is you come back to the law of sines, but this time you're going to be looking at finding c. So put little c on top, and then you want the sine of angle c, and you've got to do this twice. You got to do this when c is 125 degrees. Then you're going to need to also do it when angle c is just 5 degrees. And then I normally go and set up my other ratio using a piece of the given information. So that had to do with angle b. Okay, so I have to figure out both of those. And for both of these, I'm just going to wind up multiplying both sides by the sine of this angle right here. So I just have to enter that to get my answer. And then here, same deal. Multiply both sides by the sine of 5 degrees. And that gives me my little c in each case. And I just have to type that in. All right, so let's do that, see what we get. 17.8 times the sine of 125 divided by the sine of 25. And I wind up with 34.5 over here. Let's see, which one did that go with? The 125. So this one is 34.5, and it said to round to nearest tenth. So that would be correct. And then when I change that to 5, excuse me, 5 degrees instead of 125, I wind up getting 3.7. So remember, the bottom triangle is going with one that's shaped like this. And so the little c being 3.7, the b being 17.8, and the little a being 21.06 kind of matches the 150. Excuse me. The 25 and the 5. And then look at the top one where c is this whole thing here. So it's got to be much longer. And see how c is the biggest angle, so it has to be the longest side. And so that one also makes sense. So you have to put down both answers. You have to figure out both triangles, okay? All right, so that's law of sines on 21, okay? Wanted to look at 23 because this one's just a triangle. So you have 3 sides, okay? And you're given little c, little b, and little a, and you need to find all the angles. So you can't use the law of sines. You need to use the law of cosines. And so you could make this problem a lot harder than it needs to be if you don't set it up right. If you will work on finding the biggest angle first using the law of cosine, so that would be this one since side A is the longest, then you don't have to worry about that issue you have when you do when you deal with sine, where you might have more than one triangle. So if you'll find the largest angle first, when you use the law of cosines, that'll help you here. So the law of cosine says that, and I'm trying to find the angle. So I'm going to use the one that starts off with a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And then I'm going to plug in what I know. So I know A is 8, B is 6, C is 4, and then A is what I'm looking for. So that's my only unknown. So let's do a little bit of this by hand before we go to our calculator. That'd be 48 cosine A. So these can go together. That's 30, 40, 52. All right, but you can't make basic algebra mistakes. At this level, you shouldn't be thinking things like 52 minus 48 and getting 4. You can't subtract those. They're not like terms. So what you would do at this point is subtract 52. That's going to give you 12 equals negative 48 cosine A. So I want to get the cosine A by itself. So I'm going to divide both sides by negative 48. So I wind up with cosine A equaling negative 1/4. I just rewrote it so cosine A was on the left side. All right, so to find A, I need to do inverse cosine of negative 1/4. And see, with cosine, it'll give you something in the first or second quadrant. So if you have, and if the angle is supposed to be obtuse, it'll give it to you because it'll report an angle over there in the second quadrant. So I'm going to go to my calculator and do inverse cosine of a negative 0.25 or negative 1/4. And it'll tell me the angle. And it turns out to be about 104.5. And it said to round to the nearest tenth. No, it didn't. It said round to the nearest degree on angles. So I would round that to a, well, if I rounded that to the nearest degree, it came out to be this, then I would round it to 104 degrees. All right, now once you get that angle is 104 and you put that in, you still have more work to do. But now, see how you have a side opposite an angle, you're able to now go from here using the law of sines. Okay, so to find angle B, you can do sine B over 6 has to equal the sine of A, which is 104, over 8, and then go from there to get B. And then once you get B, you can just take 180 minus the value for A minus the value for B, and that's going to equal your C. So I won't take the time to do that. That's not the place where people typically have problems. It's usually there in the very beginning. Okay, so that one required the law of cosine. So you want to make sure you have all your formula sheets handy, that you know kind of the intent of what you're going to do, and then you just get to it. Okay. All right, now let's see. I wanted to do one more on this one. Wanted to look at question 25, which is a word problem, and I didn't want to draw it until I was reading it to you. So this one says 2 airplanes leave an airport at the same time. Okay, so they're going to leave an airport at the same time. Okay, one of them is going to go northwest. They're going to go north and then veer 35 degrees to the west. Okay, where this is 35 degrees right here. And they're going to do that. They're traveling at 416 miles per hour. The other one's going east. Okay, so this one's going east at 325 miles per hour. And straight east, 325. Okay, And then it says, how far apart are the planes after 2 hours? So this one's going that much per hour, and the other one is going 416 miles per hour. So that's kind of the picture there. And we want to know how far apart they're going to be. All right, so you might think of it like this. Let me get the arrows off the ends of those. All right. So they go 325 in an hour. So if that's 1 hour, in 2 hours, they will be this far. Okay. And then this guy was traveling north 35 degrees west, and he was going for 2 hours. I got that. That needs to be longer. So he went 416 miles and then another 416 miles, and he might be like right there after 2 hours. And we want to know this. So the length of this piece is going to be 2 times 416, and the length of this piece is going to be 2 times 325. And what we need is that piece right there. Okay, so I need this angle. Can you see that that angle is going to be 35 and 90? Okay, it's going to be 90 plus 35, so that's going to be 125 degrees. So this angle right here is 125 degrees. Okay, and then let me go ahead and do 2 times that would be 832. 2 times that would be 650. So that's the length of those two sides, and now it's just a straightforward law of cosine problem. Okay, x squared would equal 832 squared plus 650 squared, adjusted a little bit, minus 2 times 832 times 650 times cosine of 125 degrees. And so basically you just have to work that out to get what's going to happen on that one. I just wanted to kind of get the setup done for you there. All right, so I think you can finish the rest of that and then check your answer and see. All right, so